So we are now moving into the world of patterns and relations and equations. We are still sticking with algebra a little bit, but we are moving away from polynomials and going into some expression and equation work. So you are still going to need to keep in mind your sign rules and your exponent laws and your order of operations and all that stuff. But we're going to start getting a bit more visual and start looking at some patterns. And so we're looking at patterns and how do they change and how do they grow, and we're going to be looking specifically at linear patterns, so things that grow in a linear way. And I'll explain a bit more what that means. So in this first lesson, the first example we give you just is a pattern. And by the end of this lesson, we're going to be expecting you to describe patterns in words, to create a table of values from a pattern as an image, and then write the expression or the equation that represents the pattern relationship. So just to start, let's take a look at this pattern and let's start describing it in words. So the pattern starts with 1 square, and to go from figure 1 to figure 2, we have to increase by 3 squares. And so then looking from figure 2 to figure 3, again we have increased by 3 squares. Figure 3 to figure 4, we've added 3 squares. So what we could say if we're putting this pattern in words is we could say something like start with 1 square, in figure 1, and increase or add.
Katie Alalia, please come to the office.
Increase
Katie,
by
to the office.
Kent, your sister's getting in trouble. By 3 squares each time. Hi. Okay. So I forget where we were because I was a little bit distracted. There's a bunch of things going on. Let's go back to our pattern. Oh, okay. So we started with 1 and we're adding 3 every time. So now we're going to make a table of values that shows the relationship between the number of squares and the figure number. And so what we want to think about is when we build this table of values, we need to think about what value is dependent and what value is independent. And so basically which value depends on the other, which one is going to change depend on the other. So when we look at our figures, we have number of squares and we have the figure number. Well, the figure number is going to be the figure number no matter how many squares we have. And so figure number is going to be independent. Okay, and we're going to call that, let's call that n. And then the number of squares, and no, it's not a hashtag of squares, it's a number sign. We'll call that S. Okay, so the figure number is n, the number of squares is S. And so we have figures, well, we had figure 1, we had figure 2, figure 3, figure 4. And figure 1 had 1 square, figure 2 had 4 squares, figure 3 had 7 squares, and figure 4 had 10. Okay, and so just kind of to notice, we said that each time from 1 to 2, that there were 3 squares being added. And if we look in the table, as we go from one row to the next, we're going up by 3 squares. Okay? And so then it says, what is happening to n in order to get the number for s? So what is happening to the figure number to get the number of squares? And so the figure number, well, figure number we have increasing by 1. So as the figure number increases by 1, the number of squares increases by 3. So as Figure number increases by 1. Number of squares, so actually, sorry, I know that I'm going to write this smaller. So as figure number n, as n increases by 1, s, so the number of squares increases by 3. So then we need to think of, well, what pattern did they use? And so we know that we're going up by groups of 3. And so we know that we are going up, so increasing by multiples of 3. And an easier way of saying multiples of 3 is times 3. So the figure number is being times by 3, okay? So we're going 3 times the figure number. And then, well, in order to go from 3 to 1, so if we go 1 is 3, in order to get it down to 1 squares, we're going to have to take away 2. So 2 times 3, so take the figure number times by 3, that gives us 6. If we take away 2, that gives us 4. 3 times 3 is 9, take away 2 gives us 7. 4 times 3 is 12, take away 2 is 10. So our pattern is times 3 minus 2. So the figure number is multiplied by 3, so n is multiplied by 3, then decreased by 2. So if we're going to write the equation, the number of squares is equal to 3 times the figure number decreased by 2. Okay, that might seem a little bit tricky at first. The more we do them, the easier it will be. One other way that we can figure this out, and so I'm going to erase a bit of this writing, there's a lot going on here, is, so we're timesing by 3, that's how we get a multiple of 3. Now I'm going to work backwards one row. I'm going to go back to, what if there was a figure of 0? So I'm going to minus 1, and so then to go backwards for number of squares, I'm going to have to do the opposite of what we were doing if we were increasing the figure number. So opposite of plus 3 is minus 3. So if there was a figure 0, there would be 2 squares. Negative 2 squares, pardon me. 1 take away 3 is negative 2. And so whatever is at figure 0, that is our constant, right? Because if I went 3 times 0, that gives me 0. And so if we go to figure 0, that eliminates the coefficient and leaves us just with the constant. So we have a constant of negative 2. So multiplying by 3, that's our coefficient. Subtracting 2 is our constant. So 3n take away 2. Again, if that seems tricky, we'll do more of these, I promise. So now it says how many squares will be in figure 12. So what that's saying is how many squares, so what is s when n equals 12? So write our equation, s equals 3n minus 2. So s equals 3, so n is 12, so I'm going to replace n with 12. 3 times 12 is 36, take away 2, so s is 34. So there are 34 squares in figure 12. Okay, we could have continued our pattern, but using our equation or our pattern rule will help us get to our answer a lot quicker. Now it says, so which figure has 106 squares? So again, s equals 3n minus 2. Now this is a little bit more of a challenge because we haven't really done much work solving equations yet. This might seem a little tricky, but I think you can probably figure it out from what you know so far. So s is 106, so I'm going to replace s with 106, and we get 3n minus equals 3n minus 2. I want to try to figure out what n is, so I'm going to work backwards. So instead of subtracting 2, I'm going to add 2 to both sides. Minus 2 plus 2 makes a 0 pair, so it is gone. So I get 108 equals 3 times n. I don't want to know what 3 n's equal, I want to know what 1 n equals, so I'm going to divide it by 3. Whatever I do on one side, I'm going to do to the other. 108 divided by 3 is 36. 3 divided by 3 leaves us with 1 n. So that means which figure has 106 squares? Well, n is 36, so figure 36 has 106 squares. And again, if this one seems a little bit trickier, this is involving some algebra that we haven't really looked into too much yet. Okay, I know that first example was long. We're going to do this second example together, but a little bit quicker, okay? So use this pattern to answer the following question. Okay, so putting the pattern in words. So figure 1 starts with one circle, and each figure adds 2 more circles. This isn't the only way you could put it in words. There are other ways of phrasing it. We're going to make a table between the relation between the figure number and the number of circles. So again, figure number is independent. Its figure numbers are going to be the same no matter what. Doesn't matter how many circles are there. And then the number of circles. So in figure number 1, there was 1 circle. In figure number 2, there was 3, 5, and then 7. Write an equation for the relationship. So we're going to look and see, well, how much we're going up by. Well, each figure adds 2 circles, so that means 2 is my coefficient. And I'm not going to put coefficient in there. Okay, but that means I'm going 2 times the figure number. Okay, I'm going to do the work backwards method. So I'm going to go back to 0. So I'm going to subtract 1. To go back to 0, I need to do the opposite. So I'm going to subtract 2, so we get negative 2. Oops. So that means our coefficient is negative 2, because when we remove the multiplier by adding figure 0, we have a constant of negative 2. So just to double check, so we're going to check with our patterns. We're going to go times 2 minus 2. 1 times 2 is 2. Take away 2 is 1. Wait. This makes more sense. Negative 1, how about? 1 take away 2 is negative 1. There we go. This is why you check your pattern, because maybe it doesn't work. So let's try that again. 1 times 2 is 2. Take away 1 is 1. Now that works. 1 times 2, 2 times 2 is 4. Take away 1 is 3. That one works. 3 times 2, take away 1. That works. Times 2, take away 1. That works. So our pattern is a good pattern. It matches this data. Okay, so then how many how many circles are in figure 71? So when n equals 71, what is C? So we write our equation. Following BEDMAS, 142 take away 1. So in figure 71, there are 141 circles. I don't know about you, but finding the equation would be much quicker than actually drawing it out. So now it's saying which figure has 83 circles. So again, write out my equation, C equals 2n minus 1. Replace C with the number of circles, and we're going to work backwards. So instead of minusing 1, we're going to plus 1. This makes a 0 pair, so this is gone. 84 equals 2 times n. Opposite of times 2 is divided by 2. So figure number 41, whoops, 84, what was that? Here. Figure number 42 has 83 flowers. Circles. I don't know where flowers come from. All right, this is clearly struggling, so thankfully we are at the end of this video. There's nothing for you to do on your own, but I will be checking that you have this done for tomorrow.